Good evening. Thank you for turning up, those of you that did, to this last session of the day in this theatre. This is CNS208, Enhancing Container Security with Amazon Elastic Container Registry. My name's Liz Duke and I'm a Principal Specialist SA for Containers at AWS. I work with container customers across the UK, Ireland and the wider EMEA region. Every day, thousands of organizations successfully deploy containers, powering everything from your favorite streaming services to critical healthcare applications. Now, behind these seamless experiences are teams just like yours. And today, I'm excited to talk to you about how AWS services can work together to make container security feel less like a checkpoint and more like an accelerator, building in security to every stage of your container journey. Okay, let's dive in. So what are the sorts of challenges for security that you have when you're running container workloads? Well, while you may start off small with only a few container images, typically that doesn't last, and you end up managing hundreds or even thousands of container images. And each of these images needs to be checked for security, not only when they're built, but throughout the life cycle of that container image. And the more images you have, the more finding security problems. It's like finding a needle in a haystack. We expect container images to be switched out often. With this pace and this speed of change comes the ability for mistakes to affect your security profile. And container images are built up from multiple layers, typically starting off from like a base OS image layer and then adding in your application, bringing in any libraries, any further dependencies, and maybe even some open source components. All of these layers need, again, checking for any container security issues. So how do we do this? We follow and we build a container supply chain. A container supply chain is built up of the components used to build and store container images and deliver them with a container orchestrator. So we start from your code repository. This is where your application code lives. And then we build a container image up from multiple layers. And each of these layers can be pulled from almost anywhere dependent on your security constraints. Once we've built the image, we need to store it somewhere, and that's where your container registry comes into play. From then on, we use a container orchestrator to deploy your images. Now, this last step isn't typically part of a container supply chain, but I've included it because I think it's really important, and that's to monitor your images when they're up and running to see if they're behaving like you expect them to. So let's look at how we can add security into each of these stages of your container supply chain. So ideally for security, you want to automate all the stages of your container supply chain. And so that's from code submission to your repository all the way through to deploying your images on your running workloads with your orchestrator. For this, we can use a service which is AWS Code Pipeline. Now, AWS Code Pipeline works with identity and access management, so it can integrate to other AWS services using that. And when you automate this using a pipeline, you end up with taking humans out of the loop, which is a great improvement for your security. So you start off and you submit, or a developer submits code into your code repository. Now, typically these days, this is some form of Git repository. And so when that code is submitted, when it's pushed to the repository, Code Pipeline will be notified. And then it will take this new submission using a temporary access token. Once we've got the code from your repository, we want to put this code together with the other layers to build your container image. And you could use AWS Code Build for that. Now at this stage, once you've built your image, you might want to sign that image to make sure that it's not changed from when you build it to when you deploy it. And you could use a service like AWS Signer to do that. So let me introduce you to the secret weapon for your container security in your build supply chain, and that is Amazon Elastic Container Registry. It not only stores your container images, but it can also check them for vulnerabilities. And finally, we're going to deploy our container images using your orchestrator of choice. Now, within AWS, we have two main container orchestrators, and they are Amazon ECS, Elastic Container Service, and Amazon EKS, the Elastic Kubernetes Service. So once you've confirmed everything's good to go from the build point of view, then you want to get those images into your workload. So let's take a closer look at Amazon ECR and the security benefits that it brings. Amazon ECR is a fully managed Docker registry. So there's a private ECR registry that is supplied to each and every AWS account. With ECR, what you can do is you can store and distribute your Docker images, Open Container Initiative images, or any other OCI-compatible artifacts. When you transfer an image to ECR, you do so over HTTPS. So again, we're bringing security in there. And your container images are automatically encrypted at rest. Amazon ECR is highly available. It's got redundant architecture, and it actually serves billions of image pulls each and every single day. Now remember that needle in the haystack problem I was talking about? With Amazon ECR, you can use lifecycle policies, and they will automatically clean up on your behalf the old container images. Amazon ECR also comes with vulnerability scanning options, which I'll go into in a little while. So that means that when you push an image to Amazon ECR and it's scanned it, whether you have any vulnerability issues with those images. So with ECR, you can also connect to an upstream repository and cache images in your local ECR repository, and then keep those images updated using pull-through cache. So some of the inbuilt security features in Amazon ECR are the following. So Amazon ECR, again, like other AWS services, integrates with identity and access management. And so that means you can control the permissions from who's allowed to push or write images into your container registry, but also who's allowed to pull those images from your registry. And the reasons why this is important is to control people who can pull from your registry, because within your container images, quite often you will have your company IP in there. So you want to protect that IP, you want to restrict who can get those container images, and by creating the right IAM permissions, you can control that. As for pushing images into your repositories, you want to restrict who can push into your repository, because you want to make sure that all the images in your repositories conform to your company security profile. So ideally, you want to build those security checks into your pipeline as you're building the images, and you don't want people to be able to push directly into repositories, because they could include pieces of code or vulnerabilities that haven't been checked. Now, Amazon ECR uses AWS S3 for the storage for your container images. So all of these images are encrypted at rest, and we use an AWS signed key for that, an AWS owned key. Now, we don't charge you any extra for this, and this comes with AES 256 encryption inbuilt. If you decide that you want to control that encryption yourself, you can use your own KMS key with ECR to do that. Amazon ECR also supports the use of private VPC endpoints. What this means is that any data transferred to and from your registry will do so without leaving the Amazon network itself. And if this is the only type of access you need is to pull down container images, then that means you don't actually need a NAT gateway or an internet gateway from your VPC. So, I mentioned that Amazon ECR helps with vulnerability scanning. Now, there are two types of vulnerability scanning with ECR. Back in 2019, we released a basic scanning option for Amazon ECR, really just to encourage our customers to scan images. And this was based on Claire, an open source vulnerability scanner. And it scans for OS vulnerabilities only. Now, recently we updated that to use Amazon's own proprietary native technology, and this goes across more operating systems and more up-to-date operating systems. And by default, all new registries are opted into this Amazon-owned scanning technology. So what happens when you push an image to ECR? So when you push an image, either you or the pipeline pushes an image, the scanning technology kicks in and scans that image for any OS vulnerabilities. Any results from that any conflicts with any open CVEs, are returned to you within the ECR interface. But if you want to take your scanning to the next level, you can opt into enhanced container scanning. And this is where Amazon ECR integrates with Amazon Inspector. Now, Amazon Inspector not only scans for OS vulnerabilities, but also for application package vulnerabilities as well. So with the inspector scanning included, you can not only scan like your standard images, but images that are built from scratch, distroless images, and chain guard images. All of these can cause problems with more traditional vulnerability scanners. So again, what happens is when you or your pipeline pushes an image to a registry that you have opted into enhanced scanning. Now Amazon Inspector kicks in, scans that image for any application and any OS vulnerabilities. But then what it does is it prioritizes those findings and sends them to Security Hub. Why this is important is it now gives you an audit trail to follow, and that's a critical component for a lot of our customers. If there's an exploit available, it will tell you that about the image. If there's a remediation available for that exploit, it will also tell you that. And nobody here is running any end-of-life software, right? Because it will scan for that and tell you that as well. Now, in addition to the enhanced scanning, you can tell it that you want continuous scanning. What continuous scanning means is that whenever any new vulnerabilities are added to the Inspector vulnerability database, then your existing container images are also checked to see if they are affected by those vulnerabilities. And if your images that you've already put out in use in the workload are affected, you want to know, right, which of my clusters is that running in and what part of the cluster is that running in? Because it's no use you knowing about vulnerabilities if you don't know where those images are running. With the integrations with ECR and Inspector now, with both Amazon ECS and Amazon EKS, it will tell you where those affected images are running, down to the task and pod level in your clusters. So you not only know you've got affected images, you know where they're running. Pretty handy, right? So that brings us on to signing your images. So you may think that because you built your image and you scanned it, then you're good to go. But code signing is an industry standard technique to ensure that the code that you checked is the same as the code that you run. Now, as I mentioned during the container supply chain, that you can decide to integrate AWS Signer in your pipeline as you've built the image to sign that image, and then so that you know that it is unaltered from when you built it. But with that, you have to build that integration into each and every pipeline. So now I'm excited to be able to tell you, we launched this, I think, last week, that Amazon Elastic Container Registry now has fully managed container image signing that integrates with AWS Signer. So you can enable this with just a few clicks in the console or a single CLI command, and now you've got a centralized image signing tool, so you don't have to integrate in each and every pipeline. If you want to reconfirm your image before that image is then deployed onto your workload, and I strongly suggest that you do that, Amazon ECR also stores the signatures from your signed images alongside the images in the registry. And so with Amazon EKS, you can use a combination of Gatekeeper and Ratify or Caverno to detect that an image that's about to be used in the EKS cluster has a different signature from the one that was confirmed as good to go, and it will stop that. With Amazon ECS, you can also use lifecycle hooks combined with Lambda. And with that, you can check, and we've got a guide as to how to do this. You can either say, okay, I know that image doesn't match the signature, I just want to be notified about it, or you can configure it to block those images from being used in ECS as well. So it's really important for you to think about combining this with your container pipeline. And I also mentioned about monitoring your running images for unusual or suspicious behavior, and this is where Amazon Guard Duty comes in. Amazon Guard Duty supports runtime detection for both Amazon ECS and Amazon EKS. What it does is it looks for any unusual behavior. So behavior like your containers trying to connect out to the IPs of known command and control servers to make them part of a botnet. Bitcoin mining, unless you're actually Bitcoin mining in your container workload, it's looking for that sort of activity. It's also looking to see if your containers are trying to exfiltrate data out of your solution. You want to know about this, especially if it's exfiltrating data that you didn't expect it to be. So again, you can enable Guard Duty for all of your clusters or for a subset of your clusters on both ECS and EKS. So with that, I'd like to come to some key takeaways from this session. Amazon ECR stores and transmits your container images securely. It also enables you to both scan your images for vulnerabilities and to sign your images. Your security posture and your security profile needs to be continually evolving as security attacks evolve. And you should always think about whether you can integrate signing into your container workload so that you can attest that the images that you've decided are good to go from a security point of view are the ones that are actually running in your solution. We have some other sessions that are running. Well, we have quite a lot of sessions that are running, let's face it, at reInvent, but these are some security ones. And there's EKS and ECS ones here. We've got workshops, we've got builder sessions, we've got chalk talks. Now, if you're new to containers and you want to learn about ECS or EKS, we have 2 training programs. These are digital badges, and these take you from knowing nothing about container images through to knowing how each of the services is built up and how you need to think about those services. These are self-paced, so you can go at your own speed, and then at the end there's an assessment that if you do the assessment and pass that assessment, you will get a digital badge that you can then share with your employers, with your social network, and these are all free. Yeah, so you can do this on our training platform. So we've put together some session resources, so all of our container sessions are linked in a Git repository. So if you scan the QR code, you will be taken to a Git repository, and that has additional resources for all of our container sessions. It will also include some additional resources from this container session. So hopefully it wasn't too painful to come to the last session of the day at this theatre. Thank you for coming, and please fill out the session survey in the app. Thank you.